Leading European transportation and healthcare companies seek to improve their products, making them cheaper, better, and more innovative. To do so, new methods are needed to improve specification, design, analysis, and lifecycle management of safety-critical complex systems. However, this requires improved tool interoperability. The ARTEMIS-funded project Crystal will address this challenge. Currently today, the ways of working at industrial companies are often complicated and slow to adapt to change. One of the reasons for this is a fragmented IT landscape, which requires huge efforts in order to handle all of the project data. In order to improve this situation, the Crystal project suggests the introduction of a new platform layer. The idea is to connect tools in an open and standardized way following linked data principles. This will allow users to apply new engineering methods to improve their way of working. Let us explain this approach using the engineering method change impact analysis as an example. Assuming that we have our first design for our product available, this engineering method shall help users to identify the impact of a change request. For example, what data is impacted by the change request and who needs to be informed. We will use the design of a de-icing system for a regional aircraft as an example. A system that has to work safely at minimal cost, weight, and power. For such a system, we have a lot of data and many interdependencies between that data. In order to know what data is affected by a change request, we must make those dependencies explicit. We have set up a first demonstrator to show this change impact analysis method on our de-icing system example. This demonstrator is using Rational Engineering Lifecycle Manager as a main interface for the end user to assess the impact of a change request. Here is what it looks like. Remember that various data has already been defined for our de-icing system, such as requirements, design, and analysis models. This data is managed by different tools, and it may be stored in many different repositories at different sites. So, if our management wants to change, for example, a top-level requirement, how do we identify all the data that is impacted by that change request? We need a way to easily identify that impacted data and to easily navigate between that data. Realm allows us to define views to identify and navigate between the data. But to make such views, the data has to be exposed and connected using linked data concepts. In our example, we have already defined the links between the relevant data sets. Now we can define views to navigate between the project data. For example, we have defined a view where we can see all top-level functional requirements, all top-level functions, and the allocated major aircraft systems. Remember that the data is not stored here, but provided by all the tools upon request. This ensures that we always see the latest available data. Let's assume we want to change this requirement. We can request more information on this requirement. In this case, additional information is provided directly from the DOORS database where the requirement is stored. We can also explore the relationships of this requirement, for example, to a top-level function. This function is represented on a functional model in Rhapsody. We can ask for a preview of this functional model, we can navigate to that preview, and we can open the model directly from here. Now let's have a deeper look into our system under development, the ice removing system. We can see that there are alternative concepts for this ice removing system. And we can see the key system measures to compare the alternatives, for example, weight or power. We can get more information for each solution concept, such as refined functions, the product structure, and refined requirements. Let us now access the analysis view for this specific solution. We can use this view to assess the impact of change requests that are related to non-functional aspects. Here are our key system measures and the related requirements, for example, the requirement that defines the maximum allowed mean time between failure. What if we had to change this mean time between failure requirement? We can now easily identify the related analysis model. In this case, a fault tree analysis model managed by some dedicated safety analysis tool. In a similar way, if we had to change the power consumption requirement, here is the related analysis model from Simulink that we had to check. We can see that this Simulink model needs input from another model, which is a Modelica model. A combined simulation of both models is needed to confirm our new power consumption target. Let us recap. You have been watching a preview of the Crystal Change Impact Analysis engineering method. We used the Crystal platform approach with a focus on the linked data concept. We used IBM Realm to see data that is spread across many tools and locations. Now, the impact of changing data can be easily seen. We can now identify all the people that are impacted by our change request. We have correctly identified the data that needs to be changed. This will help us control the effort and risk for implementing the change request. Now we can pass the good news over to our boss.